So in this video we're going to look at surface area and volume of prisms and pyramids. So by definition, surface area is the number of square units needed to cover the surface of a three-dimensional object, and the volume is the amount of space that an object occupies measured in cubic units. And then let's move to prisms. A pyramid. So a pyramid is a polyhedron whose base is a polygon and whose faces are triangles that meet at a common point. So a pyramid does not necessarily only have a square base, even though that's what we most commonly think about when we hear pyramid. A pyramid can also have a triangle for a base or a hexagon. But yeah, let's see that in this video we're going to mainly focus on surface area and volume of pyramids per se. So let's look at a pyramid, and I'm going to try to draw one here. Oh no. And then let's say that that's in the back. So we see that in this case we have a square base pyramid, and a square base pyramid has, well, exactly that, a square base. So it's going to have a square base, and then it's going to have a triangle on each side. If you picture me opening up this pyramid, pretend this is a piece of paper, and we do the origami and fold all the sides up, and all these, this corner here, that one, and that one, they all meet up at the top. So when you look at a square base pyramid, you are really looking at a square and four triangles. So when we talk about the surface area, it's fairly simple. You have the base, the area of the base, and then you add the area of each triangle, but there's four of them, so we're gonna do for a triangle. So if in this case, let's say the one side of the pyramid ran up. Well, no, you can't use that. Let's say I was given this middle length here. If you look at a big pyramid, let's say I was given the length of this middle part right here. Then I could use, because this would be my height, and then the measurement this way would be my base, and that allows us to use the formula for a triangle, BH over 2, base times height over 2. Now for the square, if you're given one side to be, let's say, this middle length here, let's say that is given to be 27.8 meters, and then that's the height of the triangle, and then I'm given a base of 35 meters. So when I'm given a base of 35, the square rectangle is going to have, the square base is going to have 35, 35, can just find the area of that by doing a simple length times width, 35 times 35. But then here we have the 4 times the base times height over 2. So if we were to plug in these two numbers over here, then we would end up with the length and the width of the square are 35 each. 35 each, and then we have 4 times the base, which is 35 still, and the height of 27.8 divided by 2. And if we do a little bit of mental math, we end up with a total of 3171. I didn't do mental math, I actually have it written here. Yeah. So now that that was basically how easy it is to find surface area of a pyramid. Let's look at volume now. So, let's say I have another square base pyramid where I'm given the height of the triangular side as 10, and then the base I'm given 8 centimeters. So when we look at the volume of the pyramid, we can use this formula. Volume equals area of the base times the height, all times 1/3. So, how can we solve for this? Let's just say that in this particular case, so one thing we're gonna have to do here is visualize the height here. When it says height, it's not referring to the length of one of the sides, it's referring to if you were to flatten out the pyramid, when all these corners meet at the very top, it's asking me for the height of the pyramid from the dead center of the pyramid to the top point. So from here to the midpoint. So that's an entirely different measurement. So here we can easily compute that. If you look at the pyramid from a side angle, we know that one side is 10. The base side is 8 centimeters. And then we have our triangle, like we're looking at it from one of the sides. And we know that the length running through this is 10. And we brings it straight up. And that we can easily find by using our good old Pythagorean Theorem, where we have our hypotenuse as 10, and then we have, let's say, I want to call it x, but I can't see it. Anyways, x squared plus 8 squared equals 10 squared, which is x squared equals 100 minus 64. Oh, sorry. My mistake. It is not 8 squared, it is 4 squared. Because if I draw it even bigger, 8 is the distance from this to that. But I want half for this triangle, so it's 4 on this side, 4 on that side. I'm getting old. So x equals 100 minus 16, which is the square root of 84, which is about 9.2-ish. So we have 9.2 as the height. So if I was to put this in now, and the area of the base is still, by area it means surface area, we still have an 8 by 8 square at the bottom. So the area is basically length times width, so that's 8 squared times 1 over 3. So now we end up with about 196 point something. But yeah, since we're working centimeters, we're gonna use centimeter cubed. Yep, we did it. So that's all for this one. Actually, let's do one more. I know I hated it when the teacher used to do that to me, but now I'm gonna do it to you. Let's look at something very quickly. Let's picture a triangular prism. Let's say we have a triangular prism, and this is equal to 3 centimeters. This length is equal to 3 centimeters. Well, basically, we have an equilateral triangle here, 3 centimeters. Even this side here, over here, that's also 3 centimeters. And then we have 12 centimeters for how long this is. And I wanted to find the surface area. The surface area here is fairly simple. We use the same trick to find the height of this triangle. We know that this is 3, this is 3, and this is 3. So the triangle we use for our Pythagorean is going to be 1.5 and 3, and then solve for x. And we just plug that in, and we get h squared plus 1.5 squared equals 3 squared. And then we do a whole bunch of mathematics, and we get 2.6. Because, 9 minus 2.25 equals 6.6, 6.75. The square root of that is about 2.6. I'll put this. So now we know that this triangle has this triangular prism has 3 rectangles, each 3 centimeters by 12 centimeters. So the surface area is equal to 3 times the surface area of the rectangles plus 2 times the area of the triangles. So now we're left with the area of the triangle. That's not area. The area of the rectangle. So we're left with, we know that 3 times 12 is the area of the thing, and we have 3 of them. And then we have 2 triangles. So 2 times, let's say the base times height, base of. So we have the triangle like this. So this is 2.6, and then this length like that is 3. So we're left with, so 2 times the base is 3 times height divided by 2. And now we could just start working our way into this. 3 times 3 is 9. 9 times 12 is 108. And then we have 2 over 2 is 1. So it's just 3 times 2.6, which is 2, 4, 6, 7.8. And that gives us about 115.8 centimeters squared. Okay, we're gonna do the volume for this too very quickly, which is much easier. The volume for this prism is basically the base, which is a triangle, times the height. So the surface area of the triangle times the height. And we know that the area of the triangle is 2.6. Area of the base is 2.6 times 3 over 2 times the height, which is 12. So that leaves us at about 46.8 centimeters cubed. So yeah, that's how easy it is to do surface area and volume of pyramids, prisms, triangular prisms. So yeah, that's how easy it is to do surface area and volume of prisms, pyramids. I hope you enjoyed this one. I shall see you in the next one.